So I am going to fix my Q point, right? For that I need to draw one line called as load line. It is called as DC load line. Why it is called as DC load line? Because I'm applying a DC voltage VCC. So this DC load line will clearly indicate where my Q point is located. So definitely if you have a line means for drawing a line, how many points you need? For drawing a straight line, how many points you need? 1 or 2 or 3?
2, sir.
I need 2 points. So how will you fix the 2 points? How will you fix the 2 points? I will be considering 1 point on x-axis. In the x-axis, you know the y value will be 0. So I will get 1 point. I will fix 1 point on y-axis where x value will be 0. So once I get the 2 points, I'll join the 2 points and I'll get the load line. Okay, same way I'm also going to do that. See, the x-axis is VCE here, y-axis is IC here. And what equation I have? I have this equation relating x and y. So first, I'll be putting for considering the axis. Assume this line is passing through y-axis means I'll be putting x is equal to 0. What is our x value here? X value is VCE. So in this equation, put VCE equal to 0. So if you put VCE equal to 0 in this equation, what will you get? If you put VCE equal to 0 in this equation, what will you get? You get VCC equal to IC into RC, or I can write IC equal to VCC by RC. This is my coordinate A. Where is my coordinate A? See here. So this point I have considered on y-axis. So x value will be equal to 0. What is x value? VCE. VCE will be made equal to 0 and I got this point. This current is the maximum current which will flow in your transistor. IC equal to VCC by RC. When will this current flow? Maximum current flow in the transistor, can anybody say? At what condition this maximum current flow will happen in your transistor?
Sir, when VC is equal to 0.
Yes, what is that condition called? Are we still in active region when you put VC equal to 0? Where is my point actually when I put VC equal to 0? I'm going to top of the point, top of the line here. So what is this region? What is this region called as? Active region is somewhere here. I am crossing the active region and I am here, right? What is this region called as?
Saturation.
Saturation. Yes, remember above the active region you have saturation, below the active region you have cutoff. So when you say maximum current is flowing, that corresponds to saturation region. So this IC equal to VCC by RC, this maximum current will flow through your BJT when the transistor is saturated. Okay. Now, one end of my line is fixed. I have to fix the second end of my line. So for fixing second end of my line, I have to consider the point where the line is going to touch your x-axis. You know, when the line is touching x-axis, the y coordinate becomes 0. So the y coordinate is going to be IC. So in the same equation, I'm going to put IC equal to 0. So if I put IC equal to 0 in this equation, what will I get? I will get VCE equal to VCC. Okay, so the other end of the line I am getting by putting IC equal to 0. When I put IC equal to 0, I am getting VCE equal to VCC. So the other end of the coordinate I got, it is this point, B. B point is VCE equal to VCC. So when will you output voltage from a transistor? When the voltage is going to be maximum, what can you say about current? When the voltage is maximum, see here VCE equal to VCC. VCC is 12 volt, so an entire output across VCE. So when will this condition happen? IC equal to 0. We substitute IC equal to 0, which means that there is no current flowing in my device. So what is that condition called as? What is that? It is
Cutoff region, sir.
Cutoff condition. Very good. So you see here, for finding the active region point, we are finding the two ends of the active region which are going to be cutoff and saturation. Or I can say the DC load line will comprise of all the three operating points: cutoff, active region point or Q point, and the saturation point. So if I join A and B, That is called as my DC load